Okay, in section 6.5, we are going to be solving some trigonometric equations. These are equations that have trigonometric expressions in those. And really, we want to get in there and solve for the unknown, x. So it says we've worked extensively so far with identities. These are equations that are true for all values of the variable. Now we're going to look at some conditional trig equations. These are equations that are only true for some values of your variable, but not all of them. For example, it says from the unit circle, we know that, if this is our equation, cosine x equals 1/2. We're wanting to get in there and solve for x. We're basically wanting to say what are all the angles that have a cosine value of 1/2. Well, the cosine of pi over 3, 60 degrees, is 1/2. And in quadrant 4, the cosine of 5 pi over 3 is also 1/2. But then we have an infinite number of other times that we either hit angles that are coterminal with pi over 3 or with 5 pi over 3. So those would be solutions to this equation as well. Okay? Now, the way that we're going to express this set of all possible solutions of pi over 3 and 5 pi over 3 is we're going to put this term here on the end that says plus 2n pi. What n represents is it is an integer, okay? It says for an integer n. And so that's going to be complete revolutions, forward and backwards, okay? So what we're going to be getting is we're going to be, here's the graphical look at solving that equation, okay? In the blue curve, they have the cosine graphed, and in the pink line, they have y equals 1/2. Well, every time that those are the same, they intersect, is where we would have our solutions. Now, the ones that I put the orange on, okay, the little orange dots on, are the ones where x is equal to pi over 3, and then plus or minus 2n pi. Now, the ones here for like negative pi over 3 and 5 pi over 3, those are coterminal angles. Those are both down there in quadrant 4. And that is just two of the infinite number of solutions that x equals 5 pi over 3 plus 2n pi would describe. So that's really what we're looking for here on these types of problems. As an example, let's solve this equation. Now, when you go to solve a trig equation, the first thing you want to do is isolate the trig expression, the cosine. So when I go to solve this, I'm going to subtract 3 square root of 2 from both sides first. So I'll have 6 times the cosine of x equals negative 3 square root of 2. And then isolating the trig expression, I'm going to divide both sides by 6. So I have cosine x equals, now the 3 and the 6 will reduce, leaving me with a negative square root of 2 over 2. I got that by reducing the 3 and the 6. Okay? Now, we want to say what are all the values of x. Okay? All the values of x is going to be the general solution, where we have a cosine for those values of x that's equal to negative square root of 2 over 2. Now, you all know that's going to be happening where cosine is going to be a negative. Think about what quadrants. Cosine is negative in both quadrant 3. Let's do that. Let's go in order here. Sorry. Let's say it's in quadrant 2, and I'll put the quadrant 3 over here. We'll kind of go in order. In both quadrant 2 and quadrant 3. Now, we know that we're going to have a cosine value of negative square root of 2 over 2 every time we have a 45 degree or pi over 4 reference angle. And so in quadrant 2, values of x that have a cosine of negative square root of 2 over 2 are 3 pi over 4. And then we got to get every time we hit that angle in quadrant 2. So this is where we're going to say plus 2 in pi. And then in quadrant 3, the angle that has a reference angle of pi over 4 in quadrant 3 is the 5 pi over 4. And then also we want to get all of the angles that are going to be coterminal with 5 pi over 4. So when they're asking for the general solution, let me clean this up a little bit. This is what you write. Okay, we're going to write the solution set, and so it's going to be the set of all values of x such that, remember the vertical bar is read such that, and then we're going to put these two things in there, okay? Such that x is equal to 3 pi over 4 plus 2 in pi, okay? Or, maybe I should just say that instead of a comma. We'll say, or x is equal to 5 pi over 4 plus 2 in pi. That's my solution set written in set builder notation. And it's saying every time you hit an angle here in quadrant 2 or in quadrant 3 that has those that is what's the word for that? Coterminal. That's coterminal with either 3 pi over 4 or 5 pi over 4. It would check back up here into your original equation. Okay? Now that's the general solution for part A. For part B, it says write the solution set and just on the interval from 0 to 2 pi. So what we're going to do here is we're going to take our general solution set and we're going to let our n value be equal to 0. Now when n is equal to 0, for the first one, we get x is equal to 3 pi over 4 plus 2 times 0 times pi. Okay? And so that's just going to give us x is equal to 3 pi over 4. Over here, okay, when n is 0, x is equal to 5 pi over 4 plus 2 times 0 times pi. Now I'm not going to write that every time because this just turns out to be 0. So we also get in between 0 and 2 pi, the answers are going to be 3 pi over 4 and 5 pi over 4. So if we're looking for actually the solution set, the answers should be just those two numbers, 3 pi over 4, 135 degrees, okay? But we're going to write our answers in radians, 5 pi over 4. We want real numbered answers. So that is the solution set for just those angles that have a cosine value of negative square root of 2 over 2 on the interval from 0 to 2 pi. And this is the general solution. This gives all possible answers. Okay?